Right, welcome everyone. This is a webinar about material passports for the built environment. Today's lecture is by Marijn Emanuel from Madaster, which is based in the Netherlands. Marijn Emanuel is an architect and a co-founder of Madaster. Marijn will talk about circular economy principles applied to the built environment. He's going to talk specifically about the registration and documentation of products and materials used in buildings into this thing called material passports so that they can be reused in a circular economy and waste can be eliminated in the real estate sector. I want to give a big welcome to all of you in the audience. We have architecture students from the Baltimore region and from the Rotterdam region. We have architecture firms and we have other attendees from both our regions and around the world. And a very special welcome in particular to the Morgan State University students here today. In today's webinar, first, I'm saying some introductory remarks, and then Christina Murphy from Morgan State University will say some remarks. And then Marijn's going to talk for about 50 minutes or so. And after that, there will be about 20 minutes of discussion where Marijn will respond to questions from the audience. So we invite you to put your questions into the Q&A window as you have them, and we'll address them in the Q&A portion. Jeremiah Akoja, a graduate architecture student from Morgan State University, is going to moderate the Q&A portion. Thank you very much for that, Jeremiah. Before we get started, I just want to explain a little bit about Baltimore, Rotterdam sister cities and why we are hosting this webinar today. The sister cities, the two sister cities, started their relationship in 1985. At the time, Baltimore was redeveloping its waterfront, and Rotterdam was also interested in doing that as port industries were moving away from the inner harbor of the cities. The Sister City relationship is managed by the Baltimore Rotterdam Sister City Committee, and we are a group of volunteers. The committee is based in Baltimore, but we do also have some volunteers in the Netherlands that help with our activities and that are in the process of forming a committee on the Rotterdam side. We promote economic, cultural, educational, health, environmental, and other types of cooperation between the Rotterdam regions and the Baltimore regions. In recent years, many of our projects have had an environmental sustainability theme. And thanks to our collaborations now with Morgan State University School of Architecture and Planning, we're also focusing a lot on architecture and urban design. Now, I will hand over the microphone to Christina Murphy, an assistant professor at Morgan State University School of Architecture and Planning.
Thank you, Rachel, for the introduction to this lecture. Hello, everybody, and welcome to the Write It Down Instead of Writing It Off, Material Passports for the Built Environment by Marijn Emanuel. This lecture is occurring within a very exciting and continuing collaboration with Baltimore Rotterdam Committee and Morgan State University School of Architecture and Planning in Baltimore. Specifically, this webinar ties with three precedent lectures by Metabolic and Professor Di Maio and Professor Medici from TU Delft, and into SAP graduate class Architectural Technology Building Materials, which recurrent themes include origins and manufacturers of materials, construction system, maintenance of materials, and demolition strategy. Before handing over the floor to our speaker, please allow me to briefly introduce Marijn to you. Marijn Emanuel is currently working as a consultant on circular building at the WE Consultancy in Utrecht, the Netherlands. In 2017, Marijn was one of the 6 founders of Madaster, the Register for Materials of the Built Environment. Madaster's goal is to eliminate waste in the construction sector by exchanging the linear economy for a circular one. Before founding and working at Madaster, Marijn was director and architect at the office of Rauw Architects in Amsterdam. So participants, after Marijn's lecture, you're welcome and invited to ask questions. Please do so by using the question and answer button option, which is located at the bottom of the screen. We will try to answer them in order of placement. Also, you're welcome to type your general comments into the chat window, but please note that Marijn and the panelists might not see them. At this point, please turn off your video and audio with the exception of our speaker, of course, Marijn. Marijn, please take the floor.
Okay, thank you, Christina, for the introduction, and Rachel for introducing me as well, and for having me, well, present some of the work that we are looking at. I will start my presentation now, and it's, well, there are some different subjects that I would like to talk to you about. First of all, this small introduction into the circular, well, construction economy. I've understood that there were a lot previous presentations that also elaborated on it, so I will skip it a little bit quicker than maybe the amount of slides will show. And then how to become circular, and some case studies how we did it at Rauw for the last 10 years. And from there on, the lessons we learned and how Madaster came to be, what Madaster is and what it wants to achieve and how it wants to achieve it. And at the end, I will talk to you a little bit about, well, what we call the Dutch way to 2050, as the Dutch government has, well, set the goal that in 2050, the whole of the Netherlands should have turned into a 100% circular economy. And well, the initiatives that are working in that way. So, but let's start with the why for a short while. It's always good, I think, to really know why we are doing all this well, stuff and maybe strange things or difficult things. And that is, of course, that, well, we are on this planet, which is a closed system for quite some time. And yet we managed to, well, to take too much out of it and to need more than this planet can provide us. So this is what we used to do in our economy as until now, until the idea of the circular economy, that is that we take the products from the earth, we make our products, and at the end of life, we throw them away, creating a big mess of waste as a product. And this was already, well, seen for half a century almost. And in 1973, this report was produced, and they said, well, around these years, you can see all the lines going up. We will grow into an unmanageable situation. And well, the little bit scary part of it is that with the computer power of a few years ago, 2016, they recalculated all the well, all the input and the data, and they came up with more or less the same figures. So, we really, I think, have to do something different, and I think we have to do it quite quickly. Otherwise, it's going to be a lot bigger mess than we are now in. This can also be looked at in the so-called Earth Overshoot Day, as we may all know, in which some countries are doing better and some countries are doing worse. But in the end, we take too much out of the Earth than the Earth can deliver for us in a natural way. Another way of looking at it is, of course, when were you born? When will the materials or the will be gone, and how much will be left for you? So, to be able to avoid this point that everything is gone or not available anymore or not accessible anymore because it's in some kind of waste or some kind of form that it cannot be reused again, how are we going to do this? So, and that was one of the ideas of, let's say, the cradle to cradle movement, in which is that we have to look more to how the processes in nature are going. So we have to ecologize our economy in that sense, to a way of working and producing in which nothing is waste anymore. Of course, there is this whole discussion about, what is sustainability, what is circularity, and etc. And well, the way we look at it, and it's maybe a more personal way, or at least not an objective way, that is, our general goal is to have a sustainable society in which we are in balance as a society with each other and with our environment, everything that is around us, so the city, but also nature. And circularity is the principle that we can follow, and the circular economy is the means by which we want to achieve that balance. So sustainability and circularity has this form of relationship to each other. Well, this was also recognized, of course, by the United Nations with the Sustainable Development Goals, in which the building part is represented in quite a few of those goals. So if we want to become circular from this linear economy, how can we do this? Well, this was one of the topics that the Ellen MacArthur Foundation more or less 10 years ago addressed with a report. How can we become circular from this linear economy as well, in which the energy we take, it's from finite sources, and we have to take the energy from renewable sources, and we have to look at the different cycles for biological and technical materials. So they came up with this, I think well-known scheme right now, the butterfly model, in which the different kinds of loops are being identified. And with the different kinds of loops, there's also something that can be translated to other models, for instance, a value hill model, which we will address a little bit later on. But it's one of the principles that we look at when we look at the circular economy or the circular building economy. And one of the things that was very clear is that you cannot do it alone. You need the help of those people and those organizations that has all these different roles into the whole complex of building. So you need, for the whole supply chain, from the ground, the mines, for instance, to the people who make the materials, to the factories who make the products or design the products, to the builders, and then the users, of course, in the long period that buildings are used. We all need each other to keep this loop closed as good as possible. Another important thing was, of course, that this difference between the biological cycle and the technical cycle basically said there's one big principle, and that is that everything that you can, let's say, waste or that is deterred, you should make it from biological components, because those can be renewed. And everything that is technical and that cannot be renewed, that is part of this closed system in which everything is already available, we should keep it in the loop. For instance, as a product as a service model, in which you have the owner who can also take responsibility for everything that is in there. So you go to the idea of service products, in which the loop can be organized as such, for not to turn into waste. From our own consultancy group, we have this, let's say, strategies for designing for circularity, and they are 5 strategies, and they are not really No, you have to start by one, but there are just 5. So you can also start at any other point, and that's one of the principles as well for designing or for circularity, that it doesn't matter when you step into the loop. You play this part and you can go on to the next stage, So here we say, first look at what is available and utilize that. So you don't look at new products, you just first look at everything that you can reuse and everything that is available. And then as a second strategy, you can use those things that are renewable. So you have the biological materials, or you can look at the products that you can keep on reusing by, let's say, repairing it or refurbishing it, etc. As the third one, you have to look at the environmental impact, of course, because that is one of the key issues of circularity, as such that it is there to protect the environment as well, because that's also one of the scarce resources that we have. As another strategy, you can create the conditions for long cycles. So if you aren't going to build a building, how can you maintain and use it for as long as possible? Because if you don't have to reuse it, or if you don't have to make a new building to replace another one, you're doing better in terms of circular use. And as the last one, look at the way to create the conditions for future cycles. In that sense, design for disassembly, for instance, so you can disassembly the parts when they are not useful anymore or functional anymore, and then you can replace them and you can refurbish them and you can use them again. So this was also looked at by GXN, a company from Denmark, in which they also said, it's not really about the recycling of the materials or the recycling of the volume, but it's also about recycling of the value that is once invested, and you want to keep the investment and the value of a building, the products and the materials from which it consists, as high as possible for as long as possible. So what did they say for designing for circularity? They had 5 points in such, and it's a little bit like the 5 strategies from BA. So they said, you have to design for durability, the quality of the building, long life, high quality. Design for standardization, so it makes it easier to fit in and to adapt into new buildings, because all the parts are more or less standardized in a way. Design also for repairability, so you can extend the life cycle of the products and the building as a whole. And when you do that, you have to really look at the accessibility of the components, so you don't have to break something down to get to a product, to make it, to repair it, or to replace it. Design for flexibility, adaptive capacity of the internal and external structure. The adaptive component of a building as a whole for the user or for the building are two different parts. And these are really a key part for, also a longer life and higher quality of the building as a whole. Design for disassembly, one part of the design for repairability, of course, because when you want to repair something, it's very good that you can take it out, replace it for maybe a refurbished part or product, and then you can repair the one for future use. So easy to disassembly and easy to reassemble. And we can look at it in the some of the case studies that I'm going to represent right now. So I want to represent 3 case studies, or present 3 case studies from the Rauw Architectural Office that we did at the beginning of the, let's say, the years 10, from 2010-11 on until, well, right the last year. And they present different strategies to address these ideas of designing for circularity. So the first one is it's a small municipality building, and the design strategy was products as a service, as I just mentioned in the technical life cycle. And well, we framed it, or we coined it, as buildings as material banks. So all the products that were there are there on a temporarily basis. So they are there now in this building, but they can be used in another building when you want to take, let's say, your assets out of the bank. So it's there for a certain time. And you see here an old villa that was already there at the site, and the new wings of the new municipality building. So it was designed for demontage and remontage, as we called it. So all the components, big components, they were they were fit together, and they could be taken out together. And we made this contracts with the different well, subcontractors, that they would stay the owner of the, let's say, the facade. So the whole facade, it was built there by a subcontractor, and he would stay as the owner for as long as the facade would function at this building. So that was for the facade, for the roof, for the totally wooden structure of the building, and also for the technical components. So these were the five main products that were products as a service contracted for this building. So it would take this option on the future for future reuse of these parts. Well, some pictures of the of the building from I think 2013-14 when it was finished. And we also looked at, use what is already there. So there were old bricks from the old building that was demolished, and we used them, for instance, for the lower part of this building. And here you can see the big wooden structure of the building. And because well, the subcontractor, he would stay the owner, it was the subcontractor who asked us as a designer to build bigger, to make all the beams a little bit larger than was necessary for the structural dimensions, because he said, when I have to reuse it in 15 years or so, or 20 years, which was the projected lifespan of this building, then I can much more easy reuse it again for other buildings when the dimensions are not really fixed on, what is necessary only here. So it's not less material, but a little bit more material to create more value for future use. So another picture of this wing that goes around the old villa. So a second design strategy was a look at the reuse potential of your building or the components for it. And this is well, a rather oddly shaped building. It's for the headquarters of the Triodos Bank, one of the so-called green financial institutions, banks in the Netherlands. And it's in a very beautiful green well, setting. And it was determined by the local restrictions, mainly the flight of different birds and other species that were there, not to disturb it so much, and to be, to give way to the flight paths of those animals. Well, we came up with this shape. It's situated here near to a train station, and you can see how a little bit in the sketches how the form came to be. Well, we looked, of course, at the natural materials, and when you look at natural materials, it's very easy to look at the biological forms as well. The idea or the principle of biomimicry, in which you say, how is the structure for different materials in nature, because it grows like that in a very efficient way. How can we use these forms and these structures in the building itself? So that's why we came up with the big wooden cantilevered, well, let's say beams, as more or less a tree or a mushroom, for the whole structure of the building, from the main course going to the facade. And here you can see some pictures of the main course. It was one of the first building in which really the stabilizing structure, which is usually made out of concrete, where the elevators are in. They were also built from 100% from wood, solid wood and laminated wood. So all the three, let's say, towers of the building, they are stabilized by these wooden cores that are in the middle of, the mushroom-shaped building. And this is another view from the outside, a little bit more to the inside, in which you can really or clearly see how the idea of well, those natural forms came out in the final design of the main structure with the big wooden cantilevered beams. And this is a picture from the outside. And because everything is cantilevered from the inside, you can have this whole glass facades in which no really structural elements are taking place, and or are obstructing the sense of the perspective to the natural surroundings in which the building stands. So the last and third one is about a very big project that we did from 2012 on. It's the renovation of offices and the workshops in Duiven for Liander, which is a network company. They transport all the electricity and so on. And they had this building, which was an old building that was grown more or less from one building, then another one was added, and then another one was added, etc., etc. And there were some workplaces, and they came up with the idea that they needed a new office here. And first of all, they thought, well, you have this little piece of green land at the back of our lot. And let's build a new office there, and then we can use the parking spaces, etc. And then we can move when this office is ready to this new one. But he also said, we want to make an example how to make this new project as, let's say, as circular and sustainable as possible. So they thought, well, we have to do something with what we already have here. So what they already had was more the buildings themselves. They had a lot of wood. So we said, use the existing buildings, just make them better buildings by giving them also a better coat or skin around them. So that's what we did. We used 100, well, not 100%, almost 100% of the existing buildings in the whole plan. And we just made them better isolation, better skins by adding just a layer around them. And because the program was a little bit bigger than they had, they went from 600 people to in the end 1,500 people who were working there. We added the program on top of the existing buildings there. And we added a whole big atrium for the people to meet and to connect to each other. So this was the end result, in which all the existing buildings have their place in what we call an ensemble of the buildings underneath one big roof that would connect all the different buildings to one building, and that could be used as one building. And this is the view from the inside with the with the wooden new wooden skins around it. The green house or building in the middle of everything, because that was the only building that was completely underneath the roof, well, with all the natural daylight. And those new skins, you know, based on the principle of look what we have and not try to just go to the shop to buy new stuff. We picked the wood from let's say the waste incinerators and ovens, and we selected them. And in the end, those scrap woods became the new facade or the inner facade of the old buildings in this project. So this is how we tried for everything to look at what is there, what can we reuse, can we repair it and bring it back. So all these different aspects of circularity and reuse, how can we make it a better building also for the next generation of and the next life cycle of this building itself. We're in all kinds of different aspects and solutions that we proposed here. Well, one of the things if you look at circularity and if you want to make sure that the materials and the products can be used in the next life cycle, then the main principle is that you have to know what you have. You know, you have to know what's there, what's available in quite a detailed sense. So one of the things that we proposed in this competition is that we would make a materials passport for this whole complex. And we said also that in this material passport, we would prove that we would reuse at least 80% of the total of the materials that would go into the new product, into the new project. So, and these are the lists and all the data that we got from the main contractor. So he had to ask, because he didn't know it as well, he had to ask his subcontractors, and the subcontractors had to ask their product, well, the shops or the people who would make their products. So this whole idea of what I told you, the whole chain that you have to cooperate with them was really put into practice here. So in the end, we proved that based on the weight as a unit of measuring it, we got to what we call the circular use of the materials in the final project of 94%. So we, you know, we did what we promised, but we could only say this 6 months to 1 year after the project was finished. So, you know, we had to prove this as part of the competition, but we could only prove it so much later than the building was finished. And of course, that is something that you really don't want when you want to, you know, make a building as circular as possible, because maybe, you know, we were coming up short, and then you want to act on it and to move in other directions, or maybe make other decisions. So this whole idea of a material passport was good, but the way we tackled it was far from good, and much too much work for all the people. So that's why we thought of how can we tackle this problem. So the solution we came up with for material passports was to have a platform and to have the users and the builders make a passport themselves. So that's what we came up with. And you know, what is a building passport? At that time, 2011, 2013, it was really, you know, just an idea that we tried to come up with and to construct. these days there are more and better definitions for what a passport is and the ideas of it. This is one of them from this report, and it says that here it's fully digital, and it's also one part realization which acts as a single point of input, and as we look at it from the IT, a single point of truth. You have to have one place where there you can find the data that you want to use when you look at the reuse side or a more circular use of components for the next life cycle. So there are more needs that the building passport can help. You can look at it from different sides, but we saw it as one of the core problems or things that we have to address to make circularity in the building work in the future. So you can look at it from the insurance side or the valuation side. You can look at it from the regularity, compliance, depending on what the laws and regulations are. Of course, there's something like inventory generation for the the use phase of the building itself. So there are different benefits and drivers that can make people decide to have a building passport or a material passport for their project. Well, there are a few here looked at. Of course, risk mitigation. When you know what you have, there's always a lesser risk than if you don't know what you have. It's not so difficult to understand, I think. So it's also one way of looking at the SDGs, how they are come and how building passports can support the realization of, let's say, doing better and accomplishing in the end the sustainable development goals, for instance, number 9 or number 12 in that sense. So the solution we came up with, that was the Madaster platform. And I will shortly go into that now, how we think it can work. And of course, it's not the only way materials passport could work, but we think it has some principles addressed that are important. So what the title of the presentation also said, you have to write down instead of write off, because when you write it off, the value of the building goes down, well, let's say to a zero in the end, and you don't want it. You want to retain the value of your investments and your materials and your product as high as possible for as long as possible. So in order to be able to do that, you have to write down what you have. And by doing so, you can take care that the waste will not become materials will not become waste because they have lost their identity. When you write down what you have, they will retain their identity, and materials will be preserved from becoming waste. That's one of the goals of Madaster. So, and in this this vision we said, we need just one place, one platform for registration, which can function as a private, but also as a public online library of materials in the built environment, because you can make you can discuss with the owners of the building and the data at what time and in what situation this data will become available for you as a user or for the public in a broader sense. So the Madaster platform, it's a cloud-based platform where everybody can make their own material passport. So it's not a service, not a commercial service in which Madaster will make the material passports for you as a user. You have to do it yourself, and by doing it yourself, it can be more efficient, as we thought. So the Madaster platform, it has what we call it 4 clear products. It's the passport itself, of course. It's in a dossier for everything that is related to the object or the project. So it's not only the materials, but for instance, also all the guarantees or the certification documents, everything that is related to the building itself or the products and the materials as a document dossier. You can store it there at the platform. And in the end, it gives you some insights, for instance, a financial valuation, and it gives you the insight on the circularity index based on the materials. So how does it work? Well, the Madaster platform itself is more or less centered in the middle. And how it works is that we use the IFCs from the BIM models that are, becoming more and more standard way of organizing the information in the design and building process. We take that as an input. That's the primary input for Madaster. We can also go ahead with Excels if you would like that. If you have a whole management system in which all those information is set, we also have a so-called API or application program interface to address this input side. But the main input is from the BIM models, and we choose the IFC standard and not, let's say, the Revit or other formats from the different companies. But we said, we want to make it that everybody can use it, and that not only people in the Netherlands or somewhere else. So we will adapt the IFC international standard for it. So we take this IFC models from the design phase or from the building stage. We import them, we take them apart, we sort all the materials and the etc. and the products out, and we match them with the database that's in the system. So we can use our database from Madaster, which has materials in it, but you can also make your own database as a user, because in the end you only know which typical products are being used. So you can put those in your own database, and then when the import is done, there's this matching process with the databases, and then you can come up with the results that are the functionalities. Let's say the material passport or the financial valuation, and can also, of course, deliver output based on the information that is stored in there. For instance, for an online marketplace of used materials, if you're in a renovation process and you say, okay, we want to renovate all the windows, but we want to give the windows a chance on a second life. We want to give them or propose them to an online marketplace. We can also provide this information as well, also through an API way. So when you have your product in Madaster, this is more or less the first page as you see it, with some general information about the whereabouts and what the building is, where it is, the labels it has, some scores, etc., etc. And you can see on the left-hand side, you can use Madaster for many different clients or for many different projects as well. So it's not just one project or one client that you can store and use. Of course, I told you the IFC files. Most of the time in the design phase, you have a few, let's say 3 or 6 or so IFC models that comprise the whole building, the architectural, the structural, the technical one. But when you go to the building stage, that the Triodos-Bank, for instance, they had, I think, about 36 or 46 different IFC models that would make up the whole building. for a more or less as-built IFC model. So all those IFCs go into Madaster, and they can add up all the different numbers from the different IFC models. So this is the main view. After the general view, here you can see how much materials are there and how many products are there. And we choose from Madaster to have a look at it from the side of the layers of brand. I think most of you will know the classification of brand in the 6S model of classifications from site, structure, skin, services, space plan, and stuff with the different life cycle durations per per column or per S, so to speak. And on the left-hand side, you can see the different material families as we well propose. And if you click on one of those circles, for instance, it will show you how many materials and how many products are inside one of those things. So, for instance, all the structures from stone, they are there in this view. But you can also go on and on. So from this one overview, you can look at the different products, and you will see the individual products, the name of the product, and the materials from which they consist. And you can see the different kinds of information. Here you see, look at the view to the materials, but you can also see look at the products or the circularity of the product or the environmental issues or information. One of the other views we support is the view of the building process, in which the material passport supports the different stages of a renovation process. You know, when you have an existing building and you go into renovation, most of the time you demolish the few parts that are not functional anymore, and the end of it results in what we call a casco, in which is all the things that are there minus the demolition parts, and then you add new materials to it, and in the end you have your new final project. And what our experience is that, you know, you have clients that really want to know what is demolished, because they have to tell and to I'm not sure what word it is, but to make sure that what you demolish is going to the right the direction. And so they have to know what is being demolished, or they want to see that the new final project is some kind of exists from a lot of materials from the current project. So this gives you some insight into those processes there. Well, one of the things when we started with Madaster was the question, okay, you know, if you want to be circular, can you say something about how circular your building is? Well, we had a study for what we call the circularity indicator. And also there, the Ellen MacArthur Foundation had done some research into how can you measure the circularity of products. And we adapted this formula, for instance, and then we aggregated it into a whole building. And here you can see a more detailed view of the circularity indicator and the information that is needed to come up with those numbers. And this model of the Ellen MacArthur Foundation looks at 3 stages, and that is the construction phase, how much and what kind of materials go into the construction of a product, or in this case, a whole building. How circular do you use it in the use phase? And that is based on the industry standards. And Madaster looks at the years from the layers of brand as the industry standard, and then it looks at what can you do from it at the end of the life. Will it go into waste, or can it be recycled, or can it be reused? And in the end, it will come up with a weighted average, which is your score as an indicator for circularity. So the last indicator and insights that Madaster provides is insight into the financial indication, and it looks at just how much materials are there in the building, what kind for materials, and what is the market price at this moment for these materials. So then you come up with something like a current value of your building at that sense. And when you have a current value, you can also look at the historical value of all those materials. And from the historical value, you can extract something what they call an indication average for the future. So when you look at the average, you can really say, okay, based on the historical data, the value of your materials will be this and that in 5 or 10 or 15 years. So you see these values, and then when you look at how much will it cost and how much do you have to invest to detract the materials or products from the building, because then you have to demolish it maybe, or you have to get it out. How much does it cost? And then you get more or less an actual price for the materials of your building that are inside your building. So this gives some kind of financial indicator of the value of the materials and products inside your building. So that was how Madaster works with the functionalities. It's now in its third year, and it's we are expanding to different countries in Europe. Germany is the latest and biggest country that we are active in, and so we will go on to promote this idea and to offer the platform for the builders or owners for their ways of becoming a more circular building environment. So the last part of my presentation will be a little bit about how we in the Netherlands look at this whole idea of becoming circular by 2050, and especially then the building sector or the construction sector as such. Because in 2016, the Dutch government decided that the whole of the Dutch economy and society has to become circular by 2050. Because, of course, we see the problems from, let's say, the scarcity of materials, etc. So to get there, we have to really start early. So these are the targets that they proposed from 2050. If you track it backwards, they said in 2030 we have to reach a 50% target, and for 2023 the government said all the procurement that is responsible for the public sector or the government's responsibility will be what we call circular. And so we have the time until 2023 to really understand what it is to be circular and what it means when procurement is circular. And to get to know this and to do the research on this, there was this platform CB23, Circular Building 23, initiated by the government and some other parties. And I'm from Madaster, also taking part of this in this platform. And they said, on the road to 2030 and 2050, in 2023 we will, make a base camp, circular base camp, on the road there. So then we have to know more or less what we're talking about. And of course, we didn't, or the government doesn't do it just for only the nice and the environmental things. It's also because, you know, the resources, of course, it's also something that, well, costs us money. You know, we have to import, especially from a country as small as the Netherlands. We have to really import a lot of stuff, and you know that the whole, for instance, carbon footprint of mining and material production is quite large. So when we can reduce this footprint, we can do a better job. And of course, jobs, you know, it will create jobs when you make this transformation from a linear to a circular economy, because you will create just new ways of doing business, new ways of producing, new ways of designing, and there will be also new jobs because of that. So these are a few benefits that were pointed out. And in this base camp, you know, when we want to know what we are talking about in 2023, they said we have a few themes, and that is, you know, one of the things is measuring circularity. When we want to become circular, how do you know if you are circular, and how circular are you in that sense? So that was one of the things that we started with. Information and data is, of course, one of the recognized themes, and in this part of information and data, the idea of material passports is one of the subjects tackled. But of course, we also said, you know, we have to know what we are talking about, and we have to have the same idea or the same definition of what circularity means, or what some other principles mean. So one of the things that we started with is a framework and a lexicon in which all the definitions are being put up. So it was discovered that, and that's a little bit like the first part of the presentation. He said, you know, what are the main three objectives of circular building? And that is to protect the natural resources, and that's of course the materials, but it's also, especially in Holland, something like space. You know, that's really a resource that is limited, a natural resource. We have to protect our environment. We have to get rid of the carbon footprint for our buildings and products, etc. So that's also one of the main objectives. And we have to protect the value that we invest in it, because, you know, we want to go on, because it's not only circular building, it's a circular building economy. So value is a key part of being a circular economy. So how do we measure circularity? That's you know, based on the Ellen MacArthur work that is done. They looked into that. They would fine-tune it or elaborate further on it. And they said for the three main pillars of circularity, you have three different results. So you have a result when you look at measuring circularity for the stocks of materials. You have a result for the environment, and you have a result for the value retention. Well, and that goes on into something like the value hill model. Well, measuring circularity, one of the things that's also being addressed in that sense, because of course you are now and you want to say something about your future, and how are you going to do this? Adaptivity, one thing that was already mentioned earlier on. How can you make it redeployable or adjustable, etc.? And what are the themes that are being addressed when you go this way? I'm hurrying up a little bit because I see it's already quite past some time, but I'm almost there. Material passports, one of the things I said that's being addressed. So the format, what should a material passport be, so that every building has more or less the same structure of material passports, independent of the provider of the passports. So that's being laid down in what we call a norm or a standard. And then we look at the ways buildings are, well, the information is stored and let's say something like this, those layers of brand, they will come back there. And of course, you look at all the new roles that will come into play once you start building in a more circular way instead of the linear design, building, and also use process that we are used to. So I think this is something that maybe Metabolic, one of the previous presenters, came up with. Originally, my presentation was a few days before Metabolic with Meta presentations. That was, unfortunately, it didn't go on. But so this was my bridge to the presentation of Metabolic, in which they also have a very well, clear view on the subject, in which they said, you know, when we want to go on towards a circular economy, you have to take your material passport with you. So, well, thank you for your attendance and for hearing me out for such a long time, I guess.
Thank you, Marijn. Perfectly on time. Yes, and I think that I thank you also for making the link with the former lecture, because it's really important. It resonates with the students a lot, I think, and with the audience. So again, thank you, Marijn, and please keep sharing the screen so that if there are specific questions, you can go back and forth. All panelists, if you don't mind turning on your camera so our guests and attendees can see us and we can react to their questions. So students and all attendees, if not done so, please type your questions into the Q&A window located at the bottom of your screen or in the chat window. We are monitoring both. Jeremiah, hi. Please go ahead and share the collected questions with Marijn and the panelists at this point. And to all, please be informed that we would like to reach the end of all the questions. The lecture might go over 10 minutes, the agreed time. I hope you can stick with us. Thank you.
Thank you. So I'll just start reading the questions. The first question states, designing for circularity is great, but how can architects persuade the clients to purchase for circularity if good quality materials cost more?
Well, the first thing you want to do when you talk about cost is the fact, how can you make this investment stay valuable for as long as possible? And you can make a case in that if you design and build, let's say, more circular, that it's much easier to retain more value and to retain more value of his investment in the long run. Of course, you know, just like energy efficient buildings, they might cost a little bit more upfront. But when you look at it for the whole life cycle, let's say something like life cycle cost analysis, you will come up on a positive side. If you only look at the let's say at the financial side, because you can also persuade that we don't you know, we don't only live in a financial world. You know, it's hard to breathe when you only look at the financial side and value of the air that you breathe. So there are different ways of persuading clients, I think.
Okay, the next question says, how can you make sure that a product you have purchased from reclamation still has its integrity, that it hasn't been damaged or won't perform as per originally standards in terms of density, strength, and fire safety?
That's in a sense an interesting topic, because it's one of the topics that's being let's say addressed right now. You know, it's not right there, because you have those rules and regulations that you need when you want to build with new materials. So the question is, should those rules and regulations apply in the same way for existing things, because you cannot test the fire, how do you call it? The fire resistance of a door unless you burn it. You don't want to burn what you have. So you have to do it different ways. So one way is it that you have a kind of standard in the Netherlands that says something about the condition of a product. So you look at it in 5 years' time or 10 years' time, and then some assessor comes by and he assesses the condition of the product, and he delivers a certification. So this certification of the condition of the product should be, let's say, the guarantee that the product should work well or well enough for the use that you're going to use it for again. But it's not a topic that is closed right now, especially when you look at the structural things. And also, you know, we're talking about buildings now, but you also look at the infrastructure of bridges, for instance. And you know, in the Netherlands, we have quite a lot of bridges, and we want to reuse as much as possible from the existing bridges that is there. And so, how can you measure the structural integrity of the parts of the bridges? And that's one of the research that's going on right now.
Okay. The next question says, how does a customer use Madaster? Are reports generated automatically, or is processing BMI models more laborious? I can see the value of analyzing a building at multiple stages in the design process and even for figuring out small projects. Does your business encompass a lot of different building typologies? How has business changed in the last year? Are there trends you're identifying?
Start at the first one. How do you use it? You just log in. You create your product in your building, and then we have a set of requirements for your IFC models for your export from your application, and then you import it, and that's one of the work that you have to do. The other side of what I said is you have to, let's say, build or use your database to which you match your materials and products, or at least your products, because Madaster has a material database. So, but once your database is, let's say, set up and you have your good quality IFC, then it's just, you know, what we say you have to push the button and then the results come up. And then you get all the numbers of the amounts of products and from which the materials that they consist. So the work is at the front, but once you do the work well, you organize it well at the front, the use of Madaster itself is not so laborious, I think is the word. Across a lot of different building typologies. You know, we don't use it for just one typology. So any typology of building, it can be used for. I don't know if that's a good answer, but we don't not do housing, for instance, or whatever. It's just, you know, your IFC model is the basis and your database is the other part. How did this change? Well, the business is still it's still in development, or the platform is still developing, and the database side is the biggest part that we are working on, and that is changing a lot. That is one side, and the other side is, as I said, you know, we are going to other countries. So in other countries, they use different classification systems, etc. So to adapt to different classification systems is another part that the platform has to address, or has addressed in the last year. And then one thing that will keep on changing, I think, is the pricing system, because we are not really sure if we have the right pricing system for the different kind of users that are using Madaster.
Okay. Next question says, I'm a great fan of the concept of biomimicry, but wonder what the added cost might be of incorporating that into a project.
I don't know. Well, the question I have is why should it? But it's, I think when you design it well and you research, you have done your research, etc. You can have a lot of inspiration and principles from the biological structures or forms or whatever that you can use. So no, it's not like a standard IKEA shop that you go on to get your products, but it doesn't have to be cost inefficient.
Okay. The next is more of a critique. It says, it seems like it would be very difficult to achieve 100% circularity.
Yeah,
Do you have a comment?
that's true. No, it's true because, as I said, you need the whole chain to work with you to achieve it. So that's one sense, because the whole chain is still getting used to the idea that we have to become something like circular. So the people who design and produce the products itself are most of the time not circular. So you cannot make a circular building out of non-circular products, for instance. So that makes it difficult. The way the buildings are conceived is also a problem, because everybody wants to be unique, especially architects, I know. And it's something that we might look at it from different ways. So something that is unique can only be reused in, let's say, one particular way, and you would like that products or parts of buildings can be reused in a lot of different ways. For instance, let's say a wooden beam is a perfect example for you can use it in so many different ways for the next thing, because you can carve, let's say, anything out of it, for instance. But then you have to be willing to use such a thing in a certain form. But at this moment, it really, it is difficult to achieve 100% circularity. Also because, we don't really, understand what 100% circularity means. You can look at it from the more historical point of view, or how can you incorporate the future that you don't know, and how should you measure that part of the potential of circularity inside. So those are the things that have to be researched, and we hope to get there in 2023.
Okay, the next question is, reusing/renovating an existing structure must be the best way to go, like with the one project that you mentioned, which has 94%. What is the best to be expected with new construction?
Yeah, a new construction is not. It's really broad. You can go to let's say 0, but I think you can also go into the 60, 70, maybe 80%. If you use a lot of let's say renewable materials like wood for the structure. Of course, you have to understand that now you measure it, let's say, in the weight. So the structural components that weighs the most, they are the dominant factors. So if you replace concrete by wood, for instance, you are doing very well, especially. So you might not get to 100% or 94% with new wood, but if it's responsible produced wood in that sense, you will go a long way.
Okay. Next question would be, which type of person at an architecture or construction company would typically be in charge of registering the materials for a building and managing the registry?
I think that if in the design stage, I think the architect will be the more natural, let's say, coordinator of the BIM files, because as my experience is, he's the one who integrates all the different aspects of the design, the structural and the technical aspects into the whole. So he might be the more natural role or person to coordinate this. And in the building stage, most of the builders or contractors now they have some what they call a BIM director for that part, like a director for a movie. And he's the one who coordinates all the BIM files. So he's also the one who's in charge of producing a material passport in the end.
Okay, I believe this is the last question. How expensive is it to adapt a circular economy strategy in the short run? So basically, what is the benefit to go circular from an investor standpoint, especially if the investor is not interested in environmental aspect? How to make the case to the investor that the benefits are, for example, the financial benefits?
Mm-hmm. Yeah, it's a little bit my first answer to the first question. That is, it's along the financial line of keeping the value of your investment as long and as high as possible in that sense. So yeah, he has to see that when you are building circular, you have your residual value of all your materials and components will be much higher. And of course, it's more difficult when rules and regulations are not there, and that's what the point in Dutch or in Holland is for the last 4 years. Since 2016, we had these ambitions for becoming circular, but when you measure it, how we did for the last 4 years, the results are not really good. That's because everybody looks at, you have the two principles of the carrot and the stick, and everybody wants to believe in the carrot. We are going to do it ourselves as a market, but the market sticks to the old ways because that's the ways they know. And everything they don't know is a risk, and you don't want to afford risks. So you need, for a transition, you need something like a stick. And the bigger the stick, the faster the transformation goes.
Okay, we still have time for a couple more questions, so I'll just go ask the next question. In terms of plants and vegetation and trias material, how laborious is the time and expense in that process? Once again, the environmental impact is clear, yet what is the advantage in terms of time invested and expenses? This must be an attractive model for investor, correct?
Yeah, but I didn't hear well what the first part of the question was.
In terms of like the plant materials that were
Yeah.
used for the vegetation in your I believe one of
Yeah.
the concepts
Yeah.
of the example you showed earlier. So they're asking how laborious is that process of installing the plants into that design?
Well, the design was the easy part because you then say no. You have let's say specialized companies who produces those green facades, and they have even more experience now than at those days. And it was just it's it's the added layer on top of things. So it's not really such a big thing.
Okay. The last question would be for the villa project in the first case study. The subcontractor says the owner of the project lifespan is 20 years before its disablement and the material will be used. But what happens if the subcontractor's company goes out of business before the building's projected end date?
It was not done in this way because that was one of the this question always comes up when you talk about these concepts of things. But you can also look for, let's say, some kind of an insurance way that other companies will take up this contract. A little bit in the way that you have insurance companies, and insurance companies, they insure their insurances with other insurance companies, etc. And it's like when we have in Holland a kind of the where you where you put your will when you die to a certain law firm, and those law firms, they cannot go bankrupt. And when you do, there is the obligation for other companies to take, let's say, their clients. That's a legal part. So in this whole idea of products as a service, you really have to look also at the contracts and the legal part of it to address this issue. And then you have to address it in that sense.
Okay, thank you.
Might not be a very clear answer, but it's what it is more or less right now.
Yeah.
I believe, Marijn, that your lecture and your answers were very, very clear. Thank you, Jeremiah, for reading out loud the questions, and thank you, everybody, for attending this lecture. So with this, I guess we are done with this very relevant message, and I will say thank you for encouraging us to never stop exploring and proposing new designs, ways, using already proposed and already produced resources. And to all the architects, please, let's drop our uniqueness, okay? Please note that this lecture is only a part of a larger lecture series this semester. We have already entertained many, and we are going to conclude with one on April the 15th at 3:30 p.m. Eastern Time and 9:30 p.m. CET, Amsterdam time, with April De Simone with an ecology of equity. Please join us. We are announcing all of these lectures on the Baltimore-Rotterdam Committee social media, and an email announcement will be sent to everybody who registered on the Eventbrite. Please also note that the recording of this lecture, like the earlier ones, will be available via the Baltimore-Rotterdam Committee YouTube channel later on in this week. Once the upload is available, we will communicate it to all the attendees of this afternoon and evening. Once again, Marijn, thank you very much for your lecture, your messages, very strong, very necessary. Student, please become aware architects. And thank you everybody else's to have attended this lecture. Good night or good evening to you all. Thank you. Bye.
Thank you.